Hello, everyone. So I'm glad to be here in front of you all. And honestly, yeah, I just got to know yesterday, so bear with me here. And also, I'm not used to not seeing the screen of slides up close, so hopefully I get this through. So yeah, the title of my dissertation was Thermal Sensing for Automated Irrigation Management of Corn and Soybean in Nebraska. And my advisor is Dr. Derek Heeren. So I would like to start off acknowledging the funding resources Irrigation Innovation Consortium, Valley Irrigation, and Dorothy Waterfood Global Institute. They have been funding my research through my master's and my PhD as well. So really thankful for them. And then also you people from USDA, Bushland, Texas, my committee, PhD committee members, and then Eastern Nebraska Research and Extension Center, which were where my field site were, and all the personnel that helped me conduct the research there, and people from biological systems engineering as well. So a little bit background. The scientific irrigation scheduling methods can be adopted for improved crop water productivity, and that primarily could mean using less water and basically putting less pressure on our water resources, which is the mission of Dorothy Waterfood Global Institute, that to reduce the pressure on our natural resources while also optimizing the crop yield in agricultural lands. So these irrigation methods are likely to be adopted if they were reliable and automated. What I mean by automated is that the user does not need to put too much effort, like Armando was saying before, that the producers don't have much time, right? So if these methods were to automate, that would really benefit them and give them an incentive to adopt. And also, they need to be reliable. What I mean by reliable is that they need to apply less water, or we need to precisely apply water in the field. And even in the same field, plants are not uniform. Each plant is different from one another. So there could be areas that need more water, and there could be areas that need less water. So with these methods, we could really focus on precision irrigation. And then further, the common types of sensors that are being used are either soil water based or thermal sensing based. So the soil water basically estimates how much soil, how much water there is in the soil, and if the water gets below a certain threshold, we just apply water. And for the thermal sensing, the most common one is to use the infrared thermometers, which basically we try to find out how much temperature is for the leaves. If the leaf is hot, that means it's not transpiring and it probably needs water. So the research question in hand was, can these automated irrigation methods improve crop water productivity, and are they feasible for producers to adopt? So primarily, I've worked with ISSCADA system, which stands for Irrigation Scheduling, Supervisory Control, and Data Acquisition System. This system basically uses IRTs or infrared thermometer sensors mounted either on the stationary post, so they don't move around, but also we utilize the center pivot irrigation systems to mount these sensors. So the center pivot irrigation system, we can think of it as a robot, right? So it's going around the field. Why not use this as a platform to mount sensors? So that's exactly what this SCADA system does, is use the center pivots, which are already used for water application. We mount these sensors, and we basically run the system dry and collect data with it. So it can tell us which areas in the field have high crop water stress and which areas does not, and accordingly we can manage for irrigation. And this system was used for corn, soybean, in a 58-hectare field site, which had a high-speed central pivot irrigation system. What I mean by high speed is that this system was capable of going around the field in just about 4 hours, whereas the conventional pivots took about 8 hours. This gave us an advantage of collecting all the data in just 4 hours during the peak daylight hours. And as you know, if we use the thermal sensors, the time of day when we collect the data is really important. So having that ability to collect all the data during the daylight hours was a real plus for this research. And even in this figure, you can see this pivot here, and this was the mounting arm that we used for mounting this infrared thermometer sensor. So it was kind of in the forward direction of this center pivot irrigation system. Real briefly talking about the outputs. So we published one journal article already in the applied engineering and in agriculture. So if you're curious, you can look up this article. This article basically, we meant to compare all these sensors that I was using. So the sensors that I used were on the stationary post, the center pivot system, and also on the aerial systems, including the unmanned aircraft system and the satellites. So we wanted to compare all these sensing systems, how they compare to estimate these common crop parameters. We also have submitted another article in the Ag Water Management Journal, and this paper talks about the science of thermal sensing, whether it talks about stomata in the leaves and how that interacts with loss of water from the leaf and the carbon that's coming in the leaf, and how does that translate to the crop water stress, evapotranspiration, and yield. So that's already submitted, and we hope to have that published in a couple of months. And then we are preparing another article for Precision Ag Journal. And this article basically compares the ISSCADA system with the spatial evapotranspiration model, or the SETME model, that Dr. Neil and his team developed back in 2012. So we have used the SETME model now for about 8 years in Nebraska. So this paper just talks about how these two systems compare against each other in terms of crop water productivity. And then I did an oral presentation about this project in the ASABE International meeting in 2021, and plan to do one in 2022 as well. And our research was featured in the Irrigation Today magazine, which is basically by the Irrigation Association. So with that, I would like to thank you and ask any questions. Due to the limitation of time, I didn't show any results, but if you're curious, you can look up my dissertation, which will be out soon. So thanks.